Okay. Matteo DeMuro, back at it again, doing 5.6, analyzing log functions. It's a great day to do this. So, a couple things on our agenda today. We are going to look at the change of base formula, which is on your formula sheet, but we'll look at just how to use it. Handy on your calculator, because your calculator only has log base 10, so if you want to evaluate a different base, then that's what that formula is for. We are going to graph a couple more log functions, and then I'm going to wrap it up with an actual exam question just to show you how hard they are on the exam. I shouldn't say they're hard, I'm just saying what they look like on the exam. Okay, so change of base formula. So we can easily use our calculator to find log 450 because it's in base 10. That's easy peasy. But what if you had log base 3 of 28? Okay, unless you have one of the fancier calculators, you're not able to calculate that on a calculator. So there is something called the change of base formula, which basically converts anything into base 10 for us. So I'm just going to show you where it comes from. This will only take a moment. I promise you the math won't be so bad. But let's say we start with y equals log in base b of x. We're going to turn this into our change of base formula. So the first step is we're going to use our definition of a log. So we're going to say, okay, b to the power of y equals x. There we are. Now we have an equation, right? So as long as we do the same thing to both sides, it's okay. So we're going to apply log to both sides. And this is something we're going to be doing because we are going to be solving log equations. I think it's the next lesson. So apply log to both sides. Use the power law to bring the y down in front, and now you got y times log b equals log x. And you'll notice that we've gone from log in base b to just log in base 10, so that's good for our calculator. We can solve it for y by dividing both sides by log b, and you get here, and that is our change of base formula. So now we know that because y equals that and y equals that, therefore log in base b of x equals log in base 10 of x divided by log in base 10 of b. Okay, here we go. Yay! There's our log law formula again. Let's just use our calculators to do these ones. Occasionally they have one of these easy peasy lemon squeezy questions on the exam, on the calculator section. It's actually pretty funny. It doesn't happen too often. But remember, you're going to use the change of base formula so you can type this in on your calculator. So the number that goes in the top, the way I remember it, is, the formula is log x over, log b. Whereas log b is that, it's the base, and x is that. So the way I remember it is the log that has the base goes in the bottom. And you can think of the bottom like the base. So there it is. You'd be able to type that in on your calculator and get an answer. I suppose we could do that. I can find, I don't know where I put my calculator now. It's gone. I don't know where it went. Honestly, it's gone. It's literally, it disappeared. Oh, wait, it's over here. Let's see. This is the one with the faded buttons, so give me a moment. So log 100, which we should have already known was 2, and log 6. So this will give you 2.570, whatever, if you type it in on your calculator. Okay. Change your base formula again. So log x, that's log of the argument, so that's what goes in the top. So log 2 divided by log of the base, so log 3. And then you can type that in on your calculator, and you get 0.6309, whatever. Great. So that's the change of base formula. That's the easy thing for today. Now I said that we would graph a couple log functions, so let's go ahead and do that. That will be loads of fun. I can't wait. It's very important that you can just graph these basic log functions first. If you do get a log graphing question on the test, which doesn't always happen, okay, but if it does happen, you're going to want to start with the basic function. Okay, so we're not going to use a graphing calculator. We're just going to graph. So there, we're just graph y equal log base 4 of x. So where do we start? Well, I would convert it to exponential form. That is always a good first move. So we know that would be 4 to the power of y equals the argument x. All right? then make a table of values. Now, these are some basic facts that you should memorize about logs. Like, we know that the argument can't be 0 or less. So we know that there's a vertical asymptote at x equals 0. Okay? That is a fact that you should just know. So, there it is. That's a good starting point. Now what? Well, we plug in y values to get the x value. So a couple good values to do would be -1, 0, and 1 for y. So if we plug in -1 for y, we get 4 to the -1. Right? 4 to the -1 equals x. Well, that's a quarter. Okay, so boom, there's that point. You plug in 0 for y. 4 to the 0 is 1 every time. This is a point that you should memorize. The point 1, 0 is on every log graph, unless it's been shifted around and transformed, but that point will be on every basic log graph. Just like how on the power graphs, you always have the point 1, 0, 0, 1, okay? Now, last one, plug in y equal 1, you get 4 to the 1, 4. So now you have 3 points, including the intercept and your vertical asymptote, and you can sketch these things, okay? So basically, we're just going to go 1, 2, 3, 4. We'll do a couple tick marks there, a couple tick marks there. I'll do it in red. So when x is 1/4, we get -1 for y. So it just means that we're like really, really close here to the vertical asymptote. And then x is 1, y is 0. So that's that point right there. And then we have x is 4, y is 1. So right there. Right? Now we know the general shape of these kind of look like this. They are power functions that have been inversed. There. And there it is. Y equals log base 4 of x. As an exercise, we should quickly compare this to y equals to the power function, right? Because this would be the inverse of this one, all right? So what does this one look like? Well, we know we have the point when x is 0, y is 1. When x is -1, y is 1/4 right there. And when x is 1, y is 4. So here's the power function. Like that. Like that. Sometimes they get you to look at the inverse. And where's our asymptote? Well, we have a horizontal asymptote right here at y equals 0. So every time you draw a basic log graph, you should challenge yourself and see if you can draw the power function because they're related. What was the relationship again? These are inverses of each other. So this is reflected over the line y equal x, which means that any xy point on here becomes yx over here. So look, 0, 1, 1, 0, 1, 4, 4, 1, right? So please remember that. That's what this thing down here is trying to get at. So the point 4, 1 should be on our graph, right? And is it? Yeah, the point 4, 1 is on our graph. Why? Because the point 1, 4 is on the power function. I'm going crazy in here. Safely. Okay. What do we got here? Some more stuff. As with exponential graphs, we can also transform log graphs using our rules of transformation. Yes, now the exam question I'm going to show you has one transformation on it, so they never go very crazy on the log graphs. But keep in mind, the original domain of the log graph is x equals 0, or x greater than or equals 0, right? That's the vertical asymptote at x equals 0, right? There it is. It produces a vertical asymptote. And the original x-intercept is at 1, so the point 1, 0 is on every log graph. Keeping that in mind, you should be able to do some transformations. Now, they don't get quite this tricky. For graphing, sometimes on the exam, they'll give you something a little tricky like this, and they might say, oh, where's the vertical asymptote of this graph? Okay, so they're not asking us to graph it, although we will graph this one for fun. So let's see, blah, 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 yeah. Find the asymptote means keeping the log statement positive. So that's what this question is asking us. It says, can you find the vertical asymptote for this one? So where is the vertical asymptote on this one? Well, the argument has to be greater than 0. Okay, that'll help us find the vertical asymptote. So solve this equation. Right, divide both sides by 2. And there it is. So x has to be greater than 3, which means that we have a vertical asymptote right at x equal 3. All right? So there you go. Now let's go ahead and do two things here. So we're going to make a table of values and or graph this one. So we'll graph this one, and we're going to use it to do this graph. Now this is a transformed one. This question, I think, is it's a little bit trickier than what you'd see on the exam. So don't freak out too much about it, but it is a good exercise to try it. Right after this question, I will show you an actual question from the exam so you can kind of see the actual difficulty. Okay? So let's go ahead and we'll kind of sketch this graph right here. We'll make a table of values for it as well. So I'm going to just make a really, really rough sketch down here of that graph. Because it shouldn't be too hard. I know all the facts, right? Like, for example, I can get the power function. So this is 3 to the power of y equal x. Now I know this graph has a vertical asymptote at x equals 0. So there it is. I also know that it goes to the point 1, 0. I'm just going to do a couple extra tick marks here. All right. And I know the general shape is like this. I almost have enough info. I should just grab maybe a couple smart points, right? So looking at this, okay, and maybe we can make our table of values over here, right? So we already know that when x is 1, y is 0. Well, why not plug in y equal 1, right? So remember, when you're doing the inverse, you're plugging in the y value. So if y is 1, you get 3 to the 1 equals x. So the point 3, 1 is on the graph. So 3 for x, 1 for y. That's actually enough to do the sketch. Right, because we know it looks like this, and then we know it's going to go and hug that asymptote. Okay? If you wanted to grab another point, you can plug in y equals -1, and then you get 3 to the -1, which is 1/3. So we know that when x is 1/3, we're down here at -1. Okay? So there it is. This is y equals log base 3 of x. So what kind of transformations are happening here? Well, all our xy points on this graph are going to be transformed how? Well, we need to pull out the 2 because the coefficient of the x must be +1. So now we know we're looking at the graph of y equals log base 3, pull out the 2, and we get x plus 3. So now we can see the transformations to x. You always multiply by the reciprocal of that b value out there. So it's going to be 1/2 x. And then it's going +3, so it's always the opposite sign. So we're subtracting 3, and there's no changes to the y value. So that's what's happening to my xy points on this graph into that one. Now again, this is harder than what you typically see on the exam. Not all these points translate very well, like they're not very nice. So if I just grab my points from the original graph that I created, so 1, 0, 3, 1, and 1/3, -1. I can try to do these transformations, but boy, they're real ugly. Really, really ugly. Like, so 1/2 times 1 is 1/2, subtract 3. So we get like -2.50. So that's where that point went. This one is 3 times 1/2, so 3/2, which is 1.5. Subtract 3, so you get like -1.51. And then, well, that's just a nightmare. You're going to get 1/3 times 1/2, so 1/6. Who cares about that point? We know the y value stays at -1. Now, is that enough? Well, what about the vertical asymptote? That's an easy one that we can do. So the vertical asymptote was at x equals 0. Well, apply these transformations to the vertical asymptote. So 1/2 times 0 is 0, subtract 3, so you get x equal -3 as your new vertical asymptote. Now, that might be enough to get a sketch. So let's see if we need any more points. So we got vertical asymptote at -3. Now I am literally going to be doing a sketch, so I'm going to try to avoid too much doing tick marks and stuff. So we'll do the x ones and see what happens. Now we got -2.5 for x and 0 for y. So that point I would have to label. Okay, and that's important because they are going to want the x-intercept. For a log graph. And I know that the general shape of this is over here on my original graph, right? So what's happening is we're having our x values are getting compressed, and then we're shifting 3 units that way. So I know it's still going to have this shape. So I sort of know that it's going to kind of go like this, okay? The question is, where does it cross the y-axis? And that's actually tricky to do on this question, which is why this one would never actually be on the exam. We can graph this point, and then we'll leave it at that. So here's -1, -1.5. Here's 1. Okay, so our graph is going to look something like this. So this is the graph of y equals log in base 3 of 2x plus 6. Now, let me show you why that y-intercept is so tricky to figure out in this particular question. Okay, so we don't know what that is. How do you typically find the y-intercept of something? Well, you plug in x equals 0. So we can go to our function here, we can plug in x equals 0. So we get y equals log base 3, 2 times 0 plus 6. Well, what does that give us? That gives us log base 3, 2 times 0 is 0. So there, log base 3 of 6. So now you're trying to figure out, well, 3 to the power of y has to equal 6. And that is too hard to do without a calculator, right? 3 to what power equals 6? Well, 3 squared is 9. 3 to the power of 1 is 3. So I know that the answer is somewhere between 1 and 2, but without a calculator, I wouldn't be able to get an answer. So you could just label this the exact value. You could write, well, it's 0 log 3 base 6, and that would be good enough, but they would never do that to you on the exam. If they give you something to graph, it will be possible to find the x and y intercepts if they exist without a calculator, okay? So if you can graph this one, that's really good. You should be able to find the vertical asymptote. So if I just gave you this equation and said, what's the vertical asymptote? You should be able to find it. And we did that on the previous page, this exact one. You should be able to graph this one, y equals log base 3 of x. Okay? So what do these actually look like on the exam? I'm going to do a question in just a moment. I think I have one more thing. Let's just find the x and y intercept of this function. It's very similar, but it's got a -4 out here without graphing. Because sometimes they ask this question on the exam. So they'll just say, hey, what's the x-intercept? What's the y-intercept? What's the vertical asymptote? Stuff like that. So if you're finding the x-intercept, then y equals 0. Okay, so you can take this and you can go 0 equals log base 3, 2x plus 6 minus 4. Now, if I'm ever going to solve this, I need to bring the 4 over to this side so I can get it into exponential form. We'll be doing more of this in the coming lessons. We're going to be solving log equations coming really soon. So now I can put it in exponential form. So I can say 3 to the power of 4 has to equal the argument 2x plus 6. So now I can move the 6 over to this side. There we go. So 3 to the 4, I think, is 81. Subtract 6 equals 2x. So that is what? Oh boy. 76? 75, my bad. So you get 75 equals 2x. Divide both sides by 2. You get 75 over 2 equals x. And you got your x-intercept. Great. Okay? That's that one. Well, what about the y-intercept? So y-intercept means that x equals 0. Now let's see what happens when we pop in x equals 0 here. So y equals log base 3, 2 times 0 plus 6, subtract 4. So this will give me 0 in there. Well, what I mean is 2 times 0 is 0 plus 6. So you get that there. And again, you can't solve. Can't go further without some kind of technology to help me out here, right? I can't write it into exponential form, right? Because I'd have to move the 4 over here, and then I have 3 to the power of y plus 4 equals 6. It's going to be a nightmare. So can't go any further. If you were to type that in on a calculator using the change of base formula, I think you end up getting like -2.37. Okay? If they were to give this one on the exam, believe me, you'd be able to calculate it out. Okay? So that doesn't happen very often. Now, I have added this to the notes, so it's not in your original note package. If you click on the link in the description, this one is in the link, so I updated the blank one on YouTube. So this is from January 2020. Okay, so this is very recent. It's a 3-marker, and they say sketch the graph of y equals -2 log in base 3 of x. Whew, that's brutal. I need to get my coffee. It's too much. So what's the best way to graph this? Well, I would say go back to basics. Okay, so anytime you have a log graph with some transformations on it, start with the original function. Okay, so the original log graph would have been y equals log base 3 of x, right? They took this one and then they put a -2 in front of it, which is a transformation. So this one, we know how to graph that. We know how to graph that very well. We go to exponential form, right? So we go 3 to the power of y equals the argument x, and then we make an x, y table of values, and there's a couple things that we know. We know the vertical asymptote, right? We know vertical asymptote is at x equals 0, okay? What else? Well, we know the point 1, 0 is on the graph, right? When x is 1, y is 0, and we can double check. If y is 0, 3 to the 0 is 1. What else do we need? Well, how about a couple smart points? So if you plug in y equal 1, get 3 to the 1 equals x, so that's 3. And if you want one more point, just for fun, you can plug in -1 for y, and you would get 1/3 for x. That's plenty to get the original graph. I'm going to do the original graph over here in blue. Okay, so we know vertical asymptote right there. X equals 0. Let's put a couple tick marks on here. I don't know how many we're going to need. Yes. There. So when x is 1, y is 0. Perfect. When x is 3, y is 1. When x is 1/3, y is -1. So I'm not even going to label that one. You don't need to. But now we can kind of get our sketch. Whee! And there we go. There is the graph of y equals log base 3 of x. Wonder bar, wonder bar, wonder bar. Okay? Now, that would get us 0 marks on this question because we haven't done what they wanted. But we need this to get that. So now use your knowledge of transformation so you know that all those xy points on log base 3 of x are going to become what? Let's look at the transformation. So nothing's happening to the x value, so the x value stays the same. When we have a -2 in front, that means we multiply our y values by -2. So we're going to take these points and transform them doing it that way. So including the vertical asymptote. So the vertical asymptote at x equals 0. Well, is anything happening to the x values? No. So that vertical asymptote stays there. Now grab these points. So we got the point 1, 0, and we got the point 3, 1. And just for giggles, we got the point 1/3 and -1. This one's optional. We'll see if we need it. So x values stay the same. So 1, 0 times -2 is still 0. So the point 1, 0 is still on that graph. So that point is there. X value stays the same. So 3. 1 times -2 becomes -2. So now the point 3, -2 is on that graph. I don't need to label it, but I just will for giggles. X value stays the same, so 1/3, now -1 times -2 gives me +2. We need that point because it makes it very clear to me that we are now going like this. Okay, so we can see this graph has flipped. So let's go like that. Let's go hug that asymptote that way. And this is the graph of y equals -2 log base 3 of x. Now, I like to double check. So I've drawn it and I'm like, okay, here's the original. There's been a reflection over the x-axis. Does that make sense? Yes, it does, because here's a negative on the y. So when you make your y values negative, you're going to flip over the x-axis. So that makes sense. What else? Looks like it kind of got stretched. Well, yeah, that makes sense because I'm multiplying all the y values by 2. So it's going to flip and stretch. Boom. Done. That is a hard 3 marks on the exam. Not going to lie. That is probably one of the trickier questions if it comes up, because it doesn't always come up for logs on the exam. All right. So, all that being said, you may now do exercise 5.6. If you have any questions, you can contact me. Bye-bye.